Welcome, everyone. Today, we're pulling back the curtain on an incredible briefing covering one of the most highly classified, fiercely contested battlegrounds on the entire planet. And it's one we rarely even think about, the deep ocean. I mean, you know that 90% of our global trade floats on the surface, right? But what goes on beneath the waves? It's this unseen, high-stakes arms race where survival is quite literally measured in milliseconds. So let's just dive right into the apex predators of the deep: smart torpedoes, and the desperate, cutting-edge submarine defenses designed to stop them. Here's our agenda for this explainer. 1. The Predator's anatomy. 2. A global heavyweight torpedo comparison. 3. Submarine countermeasure systems. 4. The cat-and-mouse innovation timeline. And 5. The future undersea arms race. Okay, Section 1. The Predator's anatomy. To really understand these weapons, you have to realize that the ocean is just an incredibly hostile environment. We're talking crushing pressure and absolute pitch-black darkness. And that physics actually dictates how these predators have to move. So we immediately see this massive tactical trade-off: thermal versus electric propulsion. On one side, you have thermal systems using what's called auto-fuel 2. This provides raw, massive power. We're talking hitting over 65 knots. But the catch? They leave a noisy exhaust wake, and the deep water pressure actually degrades their speed. Now flip that around. Modern electric propulsion, using these advanced silver oxide aluminum seawater batteries, is virtually silent. It leaves absolutely no bubble trail, and it ignores depth pressure completely. So it really boils down to a choice between brute force and deep diving stealth. Now, one of the most insidious ways a torpedo actually finds its target is through wake homing guidance. This is really a specialty of Russian designers. Instead of just listening for engine noise like a traditional seeker, it actively looks for the physical trail of billions of microbubbles that a ship leaves behind it in the water. Once it detects that boundary, it executes this mechanical zigzag pattern from the left edge of the wake to the right, tracking that physical disturbance all the way to the stern of the ship. It's exactly like following a trail of breadcrumbs. And here's the terrifying part. Because you cannot fake a physical wake with a decoy, it is incredibly difficult to defeat. So what actually happens in those final, brutal moments of an attack? Let's walk through the terminal guidance phase. Initially, a torpedo might be wire-guided by the submarine, just stealthily listening in the dark, feeding data back and forth. But as it closes in, step 1, it severs the guidance wire. It's on its own now. Step 2, it transitions to active acoustic pinging. It starts emitting these high-frequency sonar pulses to bounce off the target's hull, calculating the exact distance and velocity using advanced phased arrays. And finally, step 3, it doesn't actually just smash into the side of the ship like you see in old movies. A magnetic proximity fuse detects the massive metal hull above it and detonates the high-explosive warhead directly underneath the ship. This creates a massive gas bubble and a shockwave that literally lifts the ship out of the water and breaks its keel right in half. It is a staggering, devastating feat of engineering.
Moving on to Section 2, Global Heavyweight Torpedo Comparison.
When we look at how the top systems in the world stack up against each other, you have to keep in mind that a lot of these specs are highly classified estimates. But they absolutely reveal clear national combat philosophies. Take the American Mk-48. It balances incredible speeds of around 65 knots and a massive 900-meter depth using that thermal auto-fuel. It's built as a deep-diving hunter. The German DM-2A4 Seehecht, however, goes totally the other way. It prioritizes a silent electric permanent magnet motor, basically sacrificing some top-end speed for absolute total acoustic stealth. And then you have the Russian 5365, which is built specifically to use that terrifying wake-homing guidance we just talked about to hunt surface ships at speeds up to 70 knots. But then, there's this outlier, 200 knots. That is over 370 kilometers per hour, underwater. The Russian VA-111 Shkval achieves this using a solid-fuel rocket motor and a mind-bending technique called supercavitation. It literally vaporizes the water ahead of it so it can fly through a bubble of its own gas, effectively removing water drag. The trade-off for all that speed? The rocket is so deafeningly loud that onboard sonar is entirely useless. It's basically a blind underwater missile. It totally sacrifices precision for raw, unavoidable speed, dropping the enemy's reaction time to basically zero. Section 3. Submarine countermeasure systems. Okay, so if you hear that high-speed propeller or that active pinging coming your way, how on earth do you survive? Well, it all starts with detection. A surface ship torpedo defense system, or SSTD, basically drags a long hydrophone cable miles behind the vessel.
Advanced algorithms are running constantly, instantly filtering out the background noise of the ocean to isolate the specific cavitation pattern of an incoming torpedo. It has to classify its guidance type and calculate the intercept probability in a split second.
Once that threat is classified, a submarine relies on desperate, incredibly high-tech defenses, which are divided into two distinct categories: soft kill and hard kill. Soft kill tactics involve tricking the torpedo sensors. This means deploying acoustic decoys, things like the Mk3 EMAD or the ADC Mk2. These are floating modules that generate massive acoustic noise to mimic the sound of a submarine, basically crossing your fingers and hoping the torpedo attacks the decoy instead. But if the torpedo is wake-homing or just too smart to be fooled, you have to rely on hard kill systems. These are essentially anti-torpedo torpedoes. Kinetic interceptors, like the Russian M15 from the Pekin-K system or Western SSTD interceptors, are literally fired out to physically collide with and destroy the incoming weapon.
The brutal reality here, the absolute crux of the issue, is time. In modern naval warfare, the window from detection to impact is just brutally short. A modern defense architecture requires a fully integrated, automated, sense-to-effect capability. It must hear the ping, classify the threat, and deploy the exact correct mix of decoys and interceptors without waiting for any human deliberation. Because honestly, if a human has to approve the launch, the ship sinks. It's that fast.
Section 4. The Cat and Mouse Innovation Timeline. You see, none of these technologies exist in a vacuum. It's a constant game of one-upmanship. Back in 1980, the U.S. deployed the Mk-48 Mod 4, specifically because they needed to hunt the incredibly fast, deep-diving Soviet Alpha-class submarines. By 1988, they had to upgrade to the 80 cap, adding wideband digital sonar just to track even quieter targets. But of course, this pushed the Soviets to rely more heavily on those decoy-resistant wake-homing torpedoes. In response to that, through the 1990s, the U.S. had to aggressively develop the SSTD program, those hard-kill interceptors we talked about, because soft-kill decoys simply weren't working anymore. The U.S. countered back again in 1997 with the Mk-48 Mod 6, which drastically reduced its own engine noise, and then in 2006 rolled out CBAS, a broadband sonar system to defeat advanced enemy jammers. Meanwhile, by the 2010s, Russia was out there upgrading their 200-knot Shkval with conventional warheads and much better guidance. Every single time one side builds a better shield, the other builds a faster, smarter spear. Finally, Section 5, the future undersea arms race. I want you to consider this question. What happens when human operators are simply too slow? With weapons closing in at 65 or, even 200 knots, intercept windows are now measured in mere seconds. The immediate future of this arms race is the total, inevitable shift toward AI-driven threat evaluation. Defensive systems are being designed right now to automatically and instantly classify incoming weapons and launch those kinetic interceptors without requiring any human intervention whatsoever. And that brings us to a really fierce debate going on right now among defense analysts. It's absolute stealth versus unavoidable speed. Will the future belong to completely silent, networked AI electric torpedoes, weapons that actually communicate with each other, sharing target data, quietly stalking a target without ever being detected until it's far too late? Or will the future be dominated by super-cavitating hypersonic weapons, rocket torpedoes moving so unbelievably fast that even if you hear them coming, your AI systems physically cannot react in time to deploy countermeasure? I want to leave you with this powerful thought from the source material. As undersea warfare becomes increasingly important in an era of great power competition, the torpedo remains a silent, deadly force beneath the waves, the ultimate hunter of the sea. The truly terrifying reality is that what we've discussed in this explainer today is only what is public. It really makes you wonder, what highly classified horrors, what silent hunters are currently being tested in the deep ocean right now? Thanks for joining me on this explainer. Keep learning, and I'll see you next time.